Okay, so good morning, students. This is a class of Geotechnical Engineering, Module 2, Part 2. So, we are coming to the end of Module 2. That is, we're discussing about CPS of soil, isn't it? So, since 2-3 classes, we're discussing about CPS of soil. We have discussed about how water flow from higher gradient to lower gradient. Okay, about Darcy's law. Okay, then Laplace equation of flow water through a porous medium. Fine. Then in the last class, we have discussed about flow net. Okay, so we can say flow net is a graphical representation of Laplace equation, and flow net is a combination of imaginary line. And this concept of flow net is very useful for study of seepage of water through a dam structure. Okay, it is very important concept. Okay, so whenever you need to go for stability analysis of dam, okay, so we have to go for to find out the pattern of the water flow or pattern of the seepage within the dam structure. So if water flow or if seepage can cross the downstream face of the dam, it may cause failure of the dam structure. Okay, we need to divert the seepage from downstream face of the dam. Okay, so let's again share my screen. So my screen is visible, right?
Yes, sir.
Okay, wait. Yeah, so in the last class, we have discussed about flow net. So flow net is what? Flow net is a representation which is drawn in scale. It is a representation of the path taken by water in passing through soil, and it is made up of flow lines and equipotential line. Here you can see the lines which are parallel to the flow direction. They are known as streamline or flow lines, and the line which are drawn perpendicular to the direction of the flow, also perpendicular to the streamline or flow line. The particular lines are known as equipotential line. And why they are known as equipotential line? It is also, we have discussed about that equipotential line, that at every section the potential drop is same, that is the head drop is same. That's why they are known as equipotential line. That means the hydraulic head or potential drop between these 2 points is same as here as well as here. Okay, equally distributed. The potential head drop are equally distributed in this manner. Okay, and this particular section, it is known as flow channel. Okay, these things are already given to you. This particular section is known as flow channel. What is flow channel? Flow channel is the section or area which are enclosed between two successive streamline. That means this is one streamline, this is another streamline, and the area between these two streamline are known as flow channel. Okay, and here you can see in this particular drawing, here right now 3 numbers of flow channels are here. It is 1, 2 and 3. You can create as many numbers of flow channel depending on the design of the flow net. Okay, and this particular area which are uh, between two successive streamline and two successive equipotential line, this enclosed area is known as field. Okay, and what is the significance of this field? It is almost approximately square. Okay, so if you can say the length of this field is denoted by small l, the width of this field is denoted by small b. So as per the property of as per the property of flow net, we can consider this field is approximately square. So we can say l is equal to b. Okay, approximately equal. Okay, not exactly, but approximately equal. Okay, so we can all there is one more significance is what you can also draw one circle touching all the sides within a field. Okay, fine. And what is the significance of the flow channel? That means the discharge through each flow channel is equal. Okay, that means that's why they are denoted by same symbol delta q. Here also delta q, here also delta q. That means the same amount of water flowing through its channel. It is assume like this. Okay, for study of the seepage. So within the dam structure, water is the flow pattern of the water is imagined in this manner to study the seepage. Okay, so there is a very important application of seepage. So we are going to discuss about the application of seepage in this class. Oh wait, yeah, regarding properties of flow net, it is already discussed in the last class. That means equipotential lines and flow lines are mutually perpendicular to each other. Fields are approximately square so that a circle can be drawn touching all the four sides of the square. Then quantity of water flowing through each flow channel is same. Even hydraulic drop or a potential drop occurs. Potential drop. Second. Potential drop occurs between the successive equipotential lines also same. Okay. And smaller the dimension of the field, greater will be the hydraulic gradient and velocity of flow through it. Okay, जितना छोटा field होगा, the the smaller will be the field, greater will be the hydraulic gradient as well as the velocity of flow. Okay, so this is all about property of flow net. So now mainly we'll discuss about application of flow net. So mainly the applications are four types of application are there. Okay, so determination of seepage, determination of hydraulic pressure, hydrostatic pressure, determination of seepage pressure, and determination of exit gradient. Okay, that is hydraulic gradient at exit point, they are known as exit gradient. So they are not that set, they are also very simple to understand. I'm giving importance to the first point, it is the application of flow net in determining the seepage. That means the amount of water, that means how much water is flowing through the dam structure or through the seepage of water. We can also find out the particular amount of water. That means we can find out the total Q, which is distributed in this field as delta Q, delta K, and delta Q. So there must be some total Q, right? This particular total Q can be determined. That is the seepage, total amount of water going through as seepage can be determined using the application of flow net by using flow net. Okay, so here determination of seepage. Now here you can see there is a figure is showing here, which is a graphical representation of a flow net. Okay, okay, the portion between any two successive flow lines are known as flow channel. It is already mentioned to you, that is this are flow channel. Okay, and what is field? The portion enclosed between successive equipotential line and successive flow lines are known as field. This is the field. All are represents field. Okay, so let's discuss how to determine discharge using flow net. So if you can draw a flow net with you, it will be better. Okay, now as you can remember that the graphical representation of flow net, let B and L be the width and length of the field. So we already discussed about field. Let assume B is the width of the field and L is the length of the field. Okay, and delta H is the head drop through the field. That means for an individual field, let's assume delta H is the hydraulic head. Okay, delta H. Fine. That means if I go again in the previous drawing, if you can see here, these all are filled and it is assumed that it's on each field the potential drop is delta H. That means here also delta H, here also delta H, here also delta H. So it will go like this. Okay, equipotential. Okay, delta H is the head drop through the field, through each field you can say, and capital H is a total hydraulic head causing flow. That means there must be a total head due to which water flow from one point to another. That particular total head is capital H, which is divided equally divided between the equipotential line as delta H. Okay, so summation of delta H will be give you total H. Okay, okay. So delta H, capital H is what? Total hydraulic head, which causing that cause for flow of the water between upstream and downstream head. Okay. Delta Q is the discharge passing through each flow channel. It is already discussed to you. Delta Q is the discharge passing through each flow channel. Our main aim to find out total discharge. Okay. Now, as per Darcy's law, we know as per Darcy's law, Q is equal to KIA. Okay. Discharge is equal to K into I into A. This is already known to you. Now, if you can use Darcy's law in this particular flow net concept. So for individual flow channel, if you write delta Q will be KIA, just simply writing the Darcy's law for each flow channel. So this one applicable for one flow channel. So delta Q equal to KIA. So K, let's say, remain constant in one direction. I will be what? I will be hydraulic gradient. That is hydraulic head divided by the length. If you consider unit thickness of a full flow net and considering a one flow field, the hydraulic gradient will be delta H by L. Delta H what? The head drop in a particular field, and length is the length of the field. That means what? Length traveled by the water. So I can be written as delta H by L, that is hydraulic gradient. Now area, cross-sectional area will be what? B into 1. Why B into 1? So if I go again in the drawing, if I go in the drawing, so water is flowing in this direction. So as per Darcy's law, Q is equal to KIA. So if I consider suppose this, okay, the first one, delta Q is equal to KIA. K will be remain constant for one direction. Okay, I will be delta H by L hydraulic gradient, and A will be your cross sectional area. That means that particular B into that particular line which is in perpendicular direction, and considering unit thickness, the thickness considering as one unit, that 1 multiply B will give you the cross sectional area. Okay, so B into 1 will give you cross sectional area. Okay, consider unit thickness, A is equal to B into 1. Okay, so we'll get the amount of water flowing through each flow channel each flow channel delta Q is equal to K into delta H by L into B. Okay. Now, since we don't know how many numbers of flow channels are there, since we don't know how many numbers of potential drops are there, because you can draw many numbers of potential drop, many numbers of flow channel. Okay, so we have to know that particular thing first before finding that total discharge through of flow net. Okay, so let's say ND represents numbers drop, total numbers of potential drop in the complete flow net. And D represents what? N for number, D for drop. Okay, so ND represents total numbers of potential drop in the complete flow net. So it can be represented by capital H by delta H. Okay, if you say indirectly, total head will be what? Total head will be unit potential drop multiply the numbers of drop, isn't it? So the numbers of potential drop can be find out by total head divided by potential drop for one field. Okay, so ND equal to capital H by delta H. From here we can find out delta H equal to capital H by ND. Okay, so just putting the value of delta H in this Darcy's equation, you can also give equation number 1 here. So delta Q can be written as K into, in place of delta H you write H by ND into this B by L. Okay, B by L will come, you can take it separately. So for one flow channel, this is the amount of water flowing for one particular flow channel. Delta Q is equal to K into capital H by ND into B by L, where ND is your numbers of potential drop. Okay, now this is for one flow channel. Okay, now if you know the numbers of flow channel, you can easily find out total discharge by just multiplying this particular value of discharge through one flow channel, multiplying with it numbers of flow channel. Okay, now if you consider NF is the numbers of flow channel in the flow net, N for number, F for flow. Okay, so NF representing numbers of flow channel, we can find out the total discharge through the complete flow net, but that is small q is equal to summation of delta q. That means all the delta q must be summed up. That means this particular things multiply by NF. Okay, that is K into H by ND into B by L into NF. So we can finally we will find the formula, standard formula of discharge through flow net, KH NF by ND into B by L. Okay, okay. Now as per the property of flow net, we know the field is approximately square. So for square field, L is approximately equal to B, so this term can be cancelled out. So finally, and which is very important formula, even for your competitive exam, this formula you have to remember that the discharge, total discharge Q is equal to KH NF by ND. K is your coefficient of permeability, H is your total head difference between upstream and downstream, NF is your total numbers of flow channel, ND is your numbers of potential drop. Okay, this is a very important formula. Q is equal to KH NF by ND. You can see for square field B is equal to L, so we can find this Q is equal to KH NF by ND. So this is the required expression for the discharge passing through a flow net, and it is valid for isotropic soil in which Kx equal to Ky equal to K. Okay, here. Okay, so whenever I already mentioned that this flow net is used for studying the seepage of water in case of dam. So here you can see a typical diagram of a dam. Okay, this is a cross-sectional view of a dam. See, say this is upstream phase, this is a downstream phase. This is a full reservoir level. This is the maximum water level here at upstream phase. Okay, and this much is a freeboard. It is already known to you. This is a creased width. Okay, fine. And if you go study seepage, it was observed that the seepage of water takes this parabolic shape. Okay, this is the flow pattern of water. Okay, this is the way the seepage occur. Okay, so this flow net can be drawn within a dam structure. Okay, so this line along the flow of the water or along the seepage of water, they are termed as flow lines. And the line drawn parallel to the upstream face of the dam, this is upstream face, parallel to upstream face of the dam, they are known as equipotential line. So by this, we can find out the actual, we can predict the flow behavior of water or seepage of water within a dam structure. Okay, so by studying, suppose that it is found that the seepage of water which take a shape of a parabola, this seepage of water cross through this downstream phase. Okay, and which is not good for stability of dam. So to divert the flow of seepage away from the downstream phase, one this particular component of dam is constructed near the downstream phase, which is known as filter. And this filter, it is made up of coarse aggregate. Okay, and having larger voids. Okay, so what it does, it do attract the flow of seepage. That means if suppose water is flowing, suppose there is a tendency of water to cross through this downstream phase, but because of the presence of the field or because of the presence of this filter, the flow will attract it towards the field. It will go like this. Okay, so all the flow seepage will go through this flow filter portion. Okay, fine. So this is a significance of the filter. Okay, you can also search in Google, you will find out. Even in your hydraulics also you will get this value, get this particular information about filter. Okay, so filter is constructed near the downstream face of the dam to safeguard the downstream phase from failure. Okay, by diverting the flow lines away from the downstream phase, and it will attract the flow lines through its to pass through it. Okay, and the top flow line, this is top flow line, right? Above this there is no flow. This is a maximum top flow line, you can say, or maximum streamline, you can say. This top flow line is known as phreatic line. Okay, so here it is definition is given. The phreatic line or top flow line is defined as the line within a dam section below which there are positive hydrostatic pressure exists in a dam. So below this phreatic line there is a hydrostatic pressure because water is flowing or water is shifts under hydrostatic pressure, and above this there is atmospheric pressure. Okay, so this phreatic line, what is the significance of the phreatic line? Phreatic line is a top flow line within a dam section below which there are positive hydrostatic pressure exist in a dam. Okay, so next class we're going to will solve one problem relating uh, with that seepage of water. Okay, okay, so understood. So this is all about today class. Is it clear? So I'm going to stop my recording here. Okay, sorry, not sorry, I'm just stopping my sharing now. I hope this is clear to you. I'm taking this as simple as so that you can understand. I'm not going in a deeper concept here. So if there is no any doubt, then I will take the attendance. Is there any doubt? Okay, so fine. Okay. So I will take the attendance then. Fine. Okay, I'm just stopping by recording first. I'm stopping by recording.